Good morning and welcome to your second e-learning day. You've by now printed out your notes outline and you're ready to fill in all these wonderful definitions. So we're going to start with the definition of a polynomial. This chapter is all about polynomials. And a polynomial is a monomial or the sum of many monomials. To refresh your memory from Algebra 1, a monomial is a number, a variable, or the product of a number and one or more variables. When we're dealing with polynomials and monomials, the exponents are always positive integers. There are no funky exponents, no negative exponents, no variables and denominators of fractions, because that, of course, would indicate a negative exponent. This lesson is going to focus on working with polynomials, adding them, subtracting them, and multiplying them. Now, when you add polynomials, you have to look for like terms. Like terms, to refresh your memory, have the same variables and exponents. When you're combining them, well, after you find your like terms, you simply add the coefficients. You keep the variable the same as well as its exponent. Don't change any of those exponents. Just add the coefficients. That's the number in front of the variable. Now to add some polynomials. When I add polynomials, I always start with the greatest exponent. And there are two methods that I'm going to go through, horizontal and vertical. I don't really typically like the vertical method, and I hope that you don't either because, well, the horizontal method is a whole lot easier to get through. All right, so when I look at the horizontal method, I'm looking for the variables with the highest powers. Make sure to consider the sign in front of that term as part of the term. So I have two terms with a fourth power. We add them together by combining, or we combine them by adding the coefficients. That's going to give us a negative 2a to the fourth power. Then I look for the next highest variable, or next highest power on my variables, and that would be the third power. So we have an 3a to the third and negative 8a to the third. And when I combine those, I simply add the coefficients. And a positive 3 and a negative 8 give us a negative 5a to the third. And then finally, I have one more term involved, and that's the 6. And since there is no other constant, no other 6, or no other just plain old number without a variable, we just tack that on to the end. And there you have your sum. If you decide you want to try the vertical method, well, then we line up our polynomials. And as I was lining these up, I was looking for the highest power in the first polynomial. I wrote first, followed by the next highest power. I wrote second. Remember to include signs. If you got a negative in front of the term, keep it with the term. If there's no sign in front of that term, it is positive. All right. Then the second polynomial, when I wrote that in its place again, I lined up each of those terms in descending order according to exponents, so the highest power first, and I lined them up so that the like exponents were right on top of each other, and therefore all we have to do is add vertically. So this gives us a negative 2a to the third and a negative a to the fourth, and a negative 5a to the third plus 6. So regardless of which method you choose, you end up with the same answer. The horizontal method is going to save us a whole lot of time because the vertical method requires us to rewrite and rearrange. This is the second example in your notes, and you'll notice it says minus in between the parentheses. Well, that was my error. It should say plus. So turn that into a plus on your worksheet or on your notes outline. And then we'll continue, and we're going to add these two polynomials by finding those like terms. So starting with the highest power. The highest power is a power of 3. It is positive 3x to the third. There are no other powers of 3. So we write down our 3x to the third. Then we look for the next highest power. The next highest power is 7x squared, and there's another 3x squared in the other term. So we'll add those two together. All we're concerned about are the coefficients, the 7 and the 3. Add them together, and you get plus 10x squared, or to the second power. Then we look for the next highest power. We're on a power of 1 now. So even though there isn't a power written there, we know that it is the first power, and they're both positive. And so we have a 2x and an 8x. We combine those, and we get 10x. And then we look for any stragglers. Here we have a straggler. This is -8. We haven't added it to anything yet, and it's the only one of its kind. So we just tack it on to the end. Okay, sometimes you'll find you have like a term in the middle of your polynomial that doesn't have a partner. It doesn't have a like term, so you just write it in there. All right, I'm going to let you guys do number 2, 3, and 4 on your own, and you can pause this until you're finished, and then check back when you're done. Okay, check your answer on number 3. On number 3, yeah, that's your answer. Double check. And then also check your answer on number 4. Position here. On number 4, there's actually 3 polynomials that you have to keep track of, or that you're adding together. So you need to find the like terms in all 3 polynomials as you're adding them together. All right, and we'll be back for subtracting in just a little bit. All right, now we're ready to subtract polynomials. When I subtract polynomial, I use the definition of subtraction, which is add opposite. So you guys did this when you were in middle school, and you did it to an extreme. And when you got to high school, we stopped you from doing this. But at this point, it's a useful tool to change all your signs. So instead of subtracting, we are going to add opposites. So the sign between the parentheses becomes addition, but every sign in the second parentheses has to change to its opposite. And then we can continue and combine like terms. So we have our like terms in number 1 now that we've done our add opposite. We have like terms of -5x to the 4th and -8x to the 4th. That will combine to give us a -13x to the 4th. The next set of like terms would be a power of 3. We don't have a power of 3, so we move on to a power of 2. You've got 8x squared and a positive 7x squared, and they combine for a positive 15x squared. And then we've got our constants, the positive 3 and the positive 1, and they combine to give us positive 4. Don't forget your signs. In between every term, you need a sign. All right, that looks pretty good. I'm going to move to the next one, and I'm going to go through that process again of adding opposites. So in number 2, 2 is also a subtraction problem. And in order to do the subtraction, we'll follow the definition and simply add opposites. So we're going to add. The opposite of p is negative p. The opposite of -3 is positive 3. I will even go as far as finding a different color when I'm working on paper, just like I have up here, to change my signs. So I remember that those aren't the original signs. Those are the signs that I've created by adding opposites. All right, and then we'll go ahead and find our like terms. I don't have any p to the 4ths other than this one. So p to the 4th is our highest power, and there's only one of them. I don't have any p to the seconds. My next highest power is p to the 1st power. There's no p to the 3rds, no p to the 2nds, just p to the 1st. And that's going to give us a -8p to the 1st power, but no need to write the power. And then finally we have the 5 and the 3 gives us 8. All right, I'm going to ask you then to do numbers 7 and 8, and then come back and we'll check on them in a minute. All right, so hopefully you've taken the time to work on number 7 and 8, and you're coming back after a pause, and you're looking at and comparing your answers to my answers. Now, as I was working these out, I color-coded them, and in the color coding, I want you to notice that after you made your sign change, so you're adding opposite all the way across, notice the 5n to the 4th and the negative 5n to the 4th. They add to give you 0. And so there is no n to the 4th term in our final answer. Hence, I drew the little arrow to show you where the blue term would have gone if we had a blue term, or an n to the 4th term. Same thing happened in number 8. You'll notice my 7n and negative 7n. When you combine, you get 0. So there's no point in writing a 0 for a coefficient because that just gives you 0. And that's the end of subtraction. We'll be moving on to multiplication shortly here. All right, so now we're ready to multiply. And we are going to start with a monomial, 2n, it's one term, times a trinomial. When you're multiplying with polynomials, the rule is you just distribute and then sometimes distribute again. So we're going to distribute the 2n to the 5n squared. Remember, the n outside the parentheses has a power of 1. And we're going to be multiplying our 5 and our 2 to get 10. And n to the first power times n to the second power. Remember, when you multiply variables with powers, you add those exponents together. So you add the 1 and the 2 for a new exponent of n to the third. Continuing on, we'll multiply the 2n times the negative 4n. And so again, we multiply, well, we know it's going to be negative, and the 2 times the 4 is 8, and n to the first times n to the first is n squared. And then lastly, we'll distribute the 2n to the negative 4. And once again, it's a positive times a negative, so you know your sign. And 4 times 2 is 8n. All right, let's move on to number 10. And number 10, again, it's a monomial, one term, times, this time it's a binomial. All right, so the story is the same. We just distribute and distribute again. All right, so 8 times 4 is 32, and n times n is n squared, and 8n times 3, well, you multiply your 8 times the 3, and that gives us 24, and then n. All right, so for numbers 11 and 12, it's a binomial times a binomial. So some of you call this FOIL. I prefer not to call it FOIL. I prefer to just think of this as distribution. And we're going to distribute the 4m to both terms. And then we're going to come back and pick up the negative 6. And we're going to distribute the negative 6 to both terms. And we know this is multiplication because when you look at these two parentheses, you don't have a sign between them. And so we know that that always means multiply. So we have 4m times m gives us 4m squared, and 4m times 7 will give us 28m. Then negative 6 times m is negative 6. Don't forget that negative sign. That's got to go, it belongs to the 6, so multiply right along with the negative and the 6. All right, and then negative 6 times 7 is negative 42. All right, so now the only thing we have left to do to finish this up is to combine our like terms. And so we have a 28m and a negative 6m, and we combine those for a positive 22m minus 42. All right, then we move on to number 12, and if you look at number 12 also has a binomial, but this time it's a binomial times a trinomial. So binomial 2 terms, trinomial 3 terms. Again, we'll start with a 2x, and we'll take that 2x and we'll distribute it. That means we're going to multiply every term in the second parentheses by 2x. Let's do that and get that out of the way before we start with the negative 7. So now we've got 8x to the third plus, right, because x to the third, because remember this has a power of 1, and we're multiplying by a power of 2, and when you multiply, you add the exponents. So now we've got 2x times 3x, and that's a positive 2, and a positive 3 gives us a positive 6x squared. Once again, power of 1 and a power of 1, multiply them together, power of 2. New 2x times a negative 8 is a negative 16x. And we're done multiplying with 2x. And now we have to move on to negative 7. Remember that negative is part of the 7. So multiply by that negative 7 all the way into that second parentheses. Okay, so we have negative 7 times 4. And notice 7 doesn't have an x, so we just keep the x squared. Then negative 7 times 3 is minus 21x. The 7, negative 7 times a positive 3 gives us a negative 21x. And then negative times a negative gives us a positive, and 7 times 8, we're at 56. We're almost done. All we have to do is combine our like terms. So we got a couple like terms here. We got a couple pair of like terms. We got a pair of x squareds. So we're going to have an 8x cubed, and then add your x squareds. That gives us a negative 22x squared. Then we have like terms with our x terms. They both have a power of 1, so they are alike. That gives us a negative 37x. And then finally, we bring our constant along, and there's the answer. I'm going to pause real quick so I can move the projector to the next board. All right, we're ready for some more multiplication. This time we have, oh, here we are. We have 3 terms, a trinomial times a binomial. So we are going to have to distribute, and then distribute again, and then distribute some more. There are 3 different terms in this first parentheses that we will have to distribute. We'll have to distribute the 7r squared, the positive 3r, and the negative 7. All of them get distributed. So we can start with the 7r squared times r. What's the power of that r? Right, it's a 1. So when I multiply, I add my exponent. So we get 7r to the third. Multiply that 7r then, or 7r squared, times the 4. And we have plus 28r squared. Moving on to 3r. We multiply 3r times the r. Again, both of those r's have powers of 1, so we add our exponents. We get 3r to the second. And then we'll multiply the 3r one more time, distribute it to the 4, and that'll give us plus 12r. One more term to distribute, and that would be the negative 7. So we take that negative 7. Remember, it's a negative. Don't lose that negative sign. And we're going to multiply it by everything in the second parentheses. So we'll have a negative 7r and a negative 28. All right, multiplication is done. Now we have to find our like terms and combine them. So we have some like terms right here in the 28r squared and positive 3r squared. So we'll combine those. And then we've got another set of like terms in the 12r and the negative 7r. So our final product, after all, when we're multiplying, we get products. So we have 7r to the third plus 31 r squared. Notice when we're combining our like terms, once again, we don't change the variable or its power. The only thing that changes is the coefficient. And there's your final answer for number 13. So we are multiplying, and when you multiply two things together, the things that you are multiplying, like this trinomial and this binomial, are considered factors. And when you multiply factors together that are polynomials, you get polynomial results. Later this chapter we'll be doing factoring, and so we'll kind of be undoing the multiplication. We'll definitely be undoing the multiplication. All right, next up, we have now a trinomial times a trinomial. So once again, lots of distribution. Just take your time and get it all done. So we're going to start with the 8a squared and multiply by 5a squared, then by a, and then finally to the 6. I think I'll stick with blue. Let's see, we've got 8 times 5 gives us 40a squared. So we multiply the coefficients. Yes, multiply the coefficients. Oh, I just totally lied to you. Multiply the coefficients and add the exponents. All right. Next up, we've got 8a squared times a positive a. So that'll be plus 8a to the third power. Remember, a has a exponent of 1. So when you add the exponent 2 and 1, you get a power of 3. Then we have plus 8 times 6 is 48 and a squared. Okay, so I'm going to kind of change things up just a little bit to show you another technique for lining up these terms and adding them. And it kind of goes back to the vertical addition method that I did show you at the very beginning of this video. So let's move on. We're going to work with the negative 6a again. Sometimes it helps to circle that term, including its negative sign, so you don't lose the negative on it. All right, so multiplying, we get negative 6 times 5 is a negative 30, and a to the first times a to the second is a to the third. So if I write that right under my other a to the third term, then they're lined up and ready to add. Move on to this negative 6a times a. Again, we add our exponents, gives us negative 6a to the second, and then finally, negative 6 times a positive 6 gives us a negative 36a. Let's move on to the positive 5. Now we take the positive 5 and multiply. We're going to distribute the positive 5 into the second trinomial. So 5 times 5 is 25, and it's just an a squared because there's no a over here, but there's an a over here, so 25a squared. We're going to line it up right underneath the other a squared terms. And then 5 times a is going to be positive 5a, lines right under the a term. And then 5 times 6 is plus 30. Okay, so now that we've got all of our terms lined up exactly where they need to be, I can't wait for you guys to critique my video skills. I have no idea how this green and pink are showing up here on your screen. Hopefully you can see them. You can let me know if you can't, and I will learn from this experience, which, by the way, I'm absolutely loving. We have 40a to the fourth, and then negative or minus 22a to the third. Now I've got a 48 and a negative 6. That takes me to 42. 42 and 25 is 67. Now you're not here to correct me when I'm wrong, so I'm going to take a step back and make sure I did that correctly. 19. Yeah, I think I like that. And then I'll go ahead and add my a terms. Negative 31a plus 30. And ta-da, we're done with multiplication. All right, so I think I just told you that we were done multiplying, but I lied. We're still multiplying. There are some special product patterns that we can use when we multiply. And the first one we're going to look at is the sum and difference pattern. And so to show you how the pattern works, we're going to use just variables A and B and do the multiplication. Now this is called a sum and difference because you look at the number or the terms in each parentheses are both the same. You got an A and a B, an A and a B. The signs, however, are different. One is a sum, the other is a difference. So if you look over at the examples that we're going to do in a minute, you've got the exact same terms, 8 V's and 7's in both parentheses. The only difference is the sign. So one is a sum, one is a difference, which is why they call this sum and difference. Look at number 17. You got N's and 3's in each parentheses. The only difference is one's plus, one's minus. Same with 16, a plus and a minus. Everything else is the same. Same with 18. The terms are the same, the signs are different. That's a good, well, that is the indicator that you're dealing with a sum and difference. And I'm going to show you a shortcut. Shortcuts are beautiful things. When patterns exist and they can be proven, then we can use them to our advantage. So we're going to use our distribution, and we're going to distribute the A times the A gives us A squared. And then A times B gives us a positive AB. Move over to the next term, the negative B. Negative B times A gives us a negative AB, and negative B times a positive. Well, you got a negative times a positive gives you a negative. But B times B gives you B squared. Now we'll go hunting for our like terms, and our like terms are positive AB and negative AB. And what happens when you have opposite signs? Well, they add to 0. So they cancel each other out, leaving us with simply A squared minus B squared. And that's how the pattern works. So when you have this situation where you see that everything's the same except for the signs, we can multiply that really quickly. All we have to do is square the first, or multiply the first terms. That's 64B squared. We know that if we multiply the outers and the inners, they're just going to drop out or cancel out like our ABs did. And then we have minus 49, and you're done. That's it. Let's move on to 16. So for 16, you get, again, the same exact terms, different signs. So you know that when you multiply this out, you're going to have to multiply the 2 times the 2, and that'll give you a 4. You're going to have to multiply the 3x and 3x, and that's going to give you a negative 9x. What happened to the middle term? Well, they became opposite. So negative 6x and a positive 6x. I'm not even going to bother writing them down because they cancel out. Negative 6x, positive 6x, gone. So we have just minus 9x squared. Quick and easy. Patterns help you. So use them when you can. N and N, that's going to give us an N squared. We know our middle terms are going to drop out, so it just is N squared minus 9. Number 18. Again, we have the exact same terms. The only difference between these two things that we're multiplying is the sign. So we know that our middle terms will drop out, and all we're going to have is the first term and the last term. Notice when we multiply, the sign in between is always minus. And that's because we get there by multiplying a negative times a positive, and a positive times a negative. So that sign in between will always be negative when you're done multiplying. All right. I'm going to go ahead and pause, clear the board, and move on to the next special pattern. All right, the second special pattern has to do with squaring binomials. So when you square a binomial, there's a pattern that emerges. And so we're going to look at that pattern, and we're going to develop that pattern by multiplying A plus, or we're squaring the quantity A plus B. So I know what you want to do. You want to get rid of that square, and you want to distribute, or FOIL, for those of you that call it FOIL. So when we do that, we're going to go ahead and do that to establish a pattern. You've got A times A is A squared. Then you've got A times B gives us plus AB. multiply the b through, we get another plus ab, and then multiply the b times the b, we get a plus b squared. All right, well, we don't really have numbers here or exponents, but we can still identify some like terms. Both of these terms have the exact same variables. So this is a 1ab and another 1ab. If we add 1ab plus 1ab, we get 2ab. So the pattern that is emerging here is thus. So you identify your A and your B, like up here, A and B. You can think of that as, and I know I hate to do this, but think of it as plus and negative until you figure out that pattern when you have a minus in there. All right, so what we're going to do is we're going to multiply, we're going to square the 7n, and then our middle term, we know there'll be two of them that'll have to be added together, so we're just going to multiply once and then multiply by 2. You'll have a 7n times a negative 6 for the middle term. And then our last term will be that negative 6 squared. All right, so 7n squared is 49n squared plus, we can do this all at once, I think. Maybe not. All right, we'll do 2 times 7 times a negative 6 is going to give us a negative 42n. And then we'll square the negative 6. And when you square a negative, you always get a positive. So this sign on the end is always going to be positive. So we have then 49n squared minus, because you got a positive 2 times a negative 42, 84n plus 36. Saves quite a bit of time because you don't have to write them out side by side and then do all the foiling and the combining of like terms. All right, let's look at number, oh, and by the way, notice when you're squaring a plus, the middle term is positive. When you square a negative, like this was originally, our middle term is negative. The last term is always going to be positive. All right, let's move on to number 20. On number 20, all right, so we know the pattern. We're going to square the 3. Then we're going to take, it's positive, so we'll use plus. So we'll take 2 times 3 times v, and then finally plus v squared. So our answer is 9 plus 6v plus v squared. And we are done. So to get that middle term, you're going to multiply the 3 times the v, and then you're simply going to double it or multiply it by 2 to get that middle term. This is the reverse of what we were doing when we were completing the square. Remember, we took that middle term and took half of it and squared it. Well, this time we're finding our middle term and we're doubling it instead of halving it. All right, on to number 21. Okay, so this is a minus. We're squaring a difference. So let's see. I think we can go right to it. We square the 2r and we get 4r squared. Don't forget, you have to square the 2 and the r. Then our middle term, well, to get our middle term, we're going to have to multiply the 2r times the negative 4. That's going to give us a negative 8r, but then we have to double it. Minus 16r, and then finally plus 16, and we are done. Next one, square the 7, 49. We know our last term is going to be plus 8b squared, which is going to be 64v. Now we have to figure out our middle term. Well, it's a difference, so our middle term will be minus, and then we multiply our 7 times our 8, that's 56v, and we know there'll be 2 of those middle terms that'll be identical. So I think that's going to give us 112v for our middle term. And we have just squared 4 binomials. There's one more special pattern, and it has to do with cubing a binomial. So we'll work that through that one, and then you can get to the assignment. All right, so the last special case is the cube of a binomial. And we're going to prove a pattern, and then we'll use the pattern to multiply numbers 23 through 26. So the pattern, if we think about this pattern as a plus b squared times another a plus b, think of it as to the first power. We can break that out because we know that when the bases are the same, we just add our exponents back together and we get back to where we started with. And the reason we break it out like this is because we know how to do a plus b squared. A plus b squared is a squared plus 2ab plus b squared. The only thing we have left to do is multiply it by one more a plus b to get all three of our factors multiplied together. All right, and we'll do our distribution. That's going to give us a to the third plus a squared b. When you're writing a term that has multiple variables, it's standard form or standard common practice, I should say, to put the variables in alphabetical order. All right, so we're done with a squared. Move on to 2ab. 2ab times a is going to give us plus 2a squared b. We're adding our exponents on the a's, the b just stays a b. Then we've got 2a b squared. This time we've got a 2 and an a, but then b times b gives us b squared. Then we move on to the b squared. B squared times a is a b squared, and b squared times b is b to the third. All right, so that looks like a really long, obnoxious pattern, and it is for now, but we are going to simplify it by combining our like terms. So let's find all of our a squared b terms. Well, here's one a squared b, and here's two a squared b. We know we can combine those to get 3a squared b. So we have a to the third from our first term. Then we combine the next two terms because they're like terms. Gives us plus 3a squared b. Notice the variables and the exponents don't change, just the coefficients. Then we move on and we have some ab squared terms. We have two of them. We have 2ab squared and 1ab squared. And when we combine them, we end up with 3ab squared. And then finally, the plus b cubed. All right, so we look at that pattern. The a and the b are both cubed on either end of the answer. And in the middle, we've got an a squared b and an ab squared. And both of them have to be multiplied by 3. All right, so let's try that up in our problems. All right, so let's look at number 23. In number 23, we're just going to follow the pattern. And the pattern is, let's see if I can color code this. A to the third plus, we're looking at this bottom line down here where we have our pattern, 3 a squared, who didn't turn their phone off? B plus 3 again, but this time it's a b squared, and then finally plus b squared. All right, so we're kind of running into number 24. We'll have to rewrite that in a minute. All right, so this is the deal. Now, I color-coded these because all of the A's are going to go in the blue parentheses, and all of the B's are going to go in the green parentheses. Okay, so we have 7x in all the green parentheses, 7x and 7x Did I say green? Blue. 7x goes in the blue, 7x in all our blues, and then we put 5 in all of our greens. And then we multiply it out. 7 to the third power, take 7 to the third power, x to the third power, plus 3 times 7 to the second power. X squared times the 5. Now we're done with that long term and we're moving on to the next term. So plus 3 times 7, well, that's easy enough. Well, we'll just write it out. 3 times 7x times 5 squared is 25. So we'll multiply all those together. And then finally plus 25. So 7 to the third power. For some reason, I think that's 343, but I also think that I'm way off. So 49 times 7 real quick, that would be 63, 28. I was right. So we have 343 x to the third power plus, now I have to do 3 times 49 times 5. All right, so we're back on to 49 times 15. And we multiply that out. Oh, I should have brought a calculator. 24 and 49, that's going to give us 5, 13, 4, 5, 6, 7. 735 x squared. Check my arithmetic and let me know if I made a mistake when you see me next block. Then we've got 3 times 7 times 25. So we have 3 times 7, that's 21, times 25, so we have 525. Sure, 525, so plus 525x plus 25. All right, so maybe that doesn't seem like such a shortcut to you. However, there is a process that you will learn about if you take pre-cal, and it involves Pascal's triangle, and it gives us these. Pascal's triangle is a way to identify these numbers right in here, the coefficients that go along with the squares and the cubes, and it makes expanding or multiplying binomials to any power a quick and easy process. Well, I shouldn't say quick, but an easy process. All right. Let's look at number 25. 25 has a subtraction sign in there. So how is that going to change things? Well, you only have to remember one pattern if you do your sign change. Okay, so let's go through the pattern again. You've got a to the third power plus a squared b plus, oh no, I totally lied to you again. You really need to stop doing that. All right, so 3a squared. Okay, I'm getting tired. I know you guys are too, and this is the last thing we're going to do, and then you can move on to whatever comes next. Plus 3ab squared plus b cubed. Okay, so once again, it's not quite color-coded parentheses, but I'm going to put a's 4 will be my a. A is 4, and it goes into all the a parentheses. So 4 is A. We put the 4 in here where an A goes, and I'm keeping my eye on that pattern over on the other side there. See my googly eyes? Keep watching that pattern. Don't take your eyes off of it unless you're plugging stuff into the parentheses. Okay, so there, all my A's are in position. Now we have to put the B's in position. And remember, B is negative 2P. How's that green showing up? I hope you guys can see it. All right, so now these are easier numbers to multiply out. All right, so we square the cube of the 4, that gives us 64. And then we have plus 3 times 4 squared is 16 times a negative 2p. Well, I'm going to take that negative and I'm going to switch the sign right here, right now, because I know a positive times a negative is going to give us a negative. And then times the 2 and the p. All right, moving on. Let's think about this sign. Well, it says plus, but is it going to stay a plus? I don't know. Maybe the negative will change it. So let's take a look at where our negative is. Oh, our negative is right here, and it's being squared. And when you square a negative, it goes positive. So we don't have to worry about that sign changing. Now we've got 3 times 4 times square the negative 2, you get 4, square the p, you get p squared. And then finally we have to raise negative 2p to the third power. Well, if I raise a negative number to an odd power, that's a negative times another negative. So there's 3 negatives, it's going to end up being negative. 2 to the third power is 8, and then p to the third power. So it looks like we're ready to wrap it up just by doing our multiplication. All right, so we got 64 minus 3 times 16 is 48, and 48 times 2 is 96p. Once again, check my arithmetic and let me know if I messed something up. 4 times 3 is 12, and 12 times 4 is 48, p squared, and then finally minus 8p to the third power. Notice something here. When we raise this thing to the third power, that thing has a subtraction in it. It was a difference. So that was subtract, this was plus. When you're doing the pluses, all your signs remain positive. But when you're cubing a difference, so there's a minus sign in there, when you're cubing the minus sign, you look at your signs, they alternate. You start with a minus, go to a plus, end with a minus. That's just the pattern. All right, thanks for listening. Wow, sorry it took so long.